actually just pulled out today. I really like teaching intermolecular forces. I don't know, I really like, and a lot of my colleagues are always like, why do you like intermolecular forces so much? And I just think there's so much, Cindy, people are always asking me. So I pulled this out. I really like this demonstration. I actually think I saw this or got this at one of the Chem Wests, and I'm going to pass it around for you. Don't inhale it too much. It is a layer of hexane and a layer of water. And then all I did, and I did this before I came today, is I colored on a piece of paper with just a pencil. And then you hole punch it. And the idea is that the graphite is going to be attracted to, or not attracted, depending on your view, is going to be touching the side of the hexane, and then the uncolored or ungraphite side is going to be touching the water. And you can shake it up, and you can see that it will always align that way. There were some old discs in this, so after a while it does kind of go away. And then I got a little overzealous today, and I put some food coloring in it, and I don't know if the food coloring is kind of interacting with the paper a little bit, but the idea, what I would do with this is if we were doing intermolecular forces or polarity, depending on how you cover that, I would actually probably make this in small test tubes, like the one that Carl just set on fire, and I would ask my students to explain why this is happening. So just tell them what you put in there, tell them hexane, water, paper with pencil on it, maybe tell them that's graphite, and ask them to come up with an explanation. And I just didn't do a handout for this because I had been thinking about this recently. I found it in one of the cabinets and was like, I really want to use this. And the idea is that in my classroom, I really try to get kids to be willing to come up with an explanation. So this would be an event that they could observe, that when you shake it, and I'll pass it around now, that you can see the colored sides align with the hexane, and the non-colored sides align with the water that's purple there. And depending on the level of class, I often give my students prompts. So I would maybe give them a collection of words like hexane, water, polar, non-polar, and ask them to come up with a constructed explanation. I like what I've seen here in that maybe then I could put some student samples up there and kind of maybe, take two that are extremes and ask the kids to describe or figure out which one they think aligns with it. But I really want my students to be brave enough or bold enough to explain just a phenomenon. And so, they'd have to look up graphite, kind of what it is and how that works. So that's just my little demonstration, and like I said, I would probably go with intermolecular forces. The other two things that I brought with me, and I'll pass this out, I made enough copies for everyone, is I mention this all the time, that the other hat that I wear is I teach a science research course. One of the things that my colleague and I did is we made this a public site now. So I've been mentioning for years that I have this curriculum that we developed, and I want to share it with people. So if you know anyone in your districts who teaches, this is a year-long science research course, and if they want to know how that's done or they're interested in the curriculum, it's here, and it's a public site, and it's just Surge Student Research, and it's a Google site. So you have to add that word Google on there or look at a Google site in order to come up to this. Otherwise, you go to one that's at IMSA, and that's not my site. But most importantly, a colleague of mine who teaches the class with me teaches biology, and I spent the summer studying computational biology. And I was blown away by how much biology has become numbers and making sense of statistics. And there were all these theoretical physicists and quantitative physicists there who now do work in computational biology. So it was like very mind-blowing. So I thought to myself, well, how can I get my students to incorporate numbers and data? And this colleague of mine mentioned to me that at the AP level, they're very interested in doing case studies and also bringing in statistics. So the two resources, the one that I'm handing out is an example of a case study. It's from this NSTA book that's come out, that's quantitative case studies you can use. And they are biology based, but what I'm challenging myself to do this year is to find one or two that I could use in my chemistry classrooms. And the reason I would use these is because I want students to be able to look at data, analyze some information. And the one that's there is simply, if you turn the pages, you'll see that it's a sample of them. You can get the better originals online, but they're looking at inhibition zones from antibiotics, and it asks them some questions and asks them to make some statistical analysis. Now, I just used this one, and again, I went with the Carl method of, I had this in my classroom, so I took it. But I used this in my research course as we're introducing statistics. But I want to find another one that I could use in my chemistry course. And they have a wide range. If you want to do conflicting scientists, if you want to do like an environmental question or anything like that, all of these case studies are there. And they're from original research. And NSTA, there's another group that does it out of New Buffalo. And they just took it one step away from the primary resources, and they made it so that you can use it in your classroom. There's a wide range of levels, and again, it's a way to bring in actual quantitative research into your classroom. And as we're all trying to do science as a process, this is a resource that I'm going to start to use this year. Oh, that's all I need. I mean, that's fine. So there's, and again, if you ever want to check that out. The last thing I brought, and I don't know if anyone's interested in this, were any of you here when Kevin Kopak presented on this journal article about woodpeckers?
No.
No? Okay, so there's a colleague of mine who I used to work with at Lane Tech, and he also wanted to bring in primary journal articles into his classroom. So he found this awesome article on why woodpeckers resist head impact injury, which is basically why don't they get concussions, right? Which we can all understand. Like that's a kind of, I never thought about that. This is a free article, so you have public access to it. I have copies if people are interested. These are actually my classroom copies. So if you aren't interested in one, I'll take them back, because otherwise I have to make new copies next year. What I found, though, in addition to this, is I found this year they did a summary of this article in Popular Science. So you can see the Popular Science version of this article, and you can see the technical journal article version of this. And so in my research class, I had a discussion about what's the difference, how do we communicate, and what I teach in the class is how do you pull the key points of information from this journal article. And what I like about it, again, this is, I don't know where Kevin first found this article, but is that, again, we can all kind of understand how a woodpecker might not get a concussion, you know, like what are some of the factors. And so my students kind of like it, and like I said, I had them also use this level, which is just a Popular Science article. And so we compared and talked about what's the difference between just a popular magazine and like a science journal. So
very cool.
That's all I got.